every day, and same kind of pressures, the same failures of policy that I see happening with health, but there is a much more direct connection to the way we produce food. The big question that I'm going to be posing today is how do we feed this population? You know, I don't know how many people think about it, but we're adding 80 million extra mouths to feed every year. And how do we do this when we have declining amount of land available for each person? The fossil fuels that, you know, I'll show you how important they are in the food that we eat. They are disappearing, not so much the actual amount of them that's the issue, but the energy return on investment. We're basically looking at, in the next 10 to 20 years, having to phase fossil fuels out of our lives, not because there won't be any fossil fuels left, but because it takes more energy to get those. We've got all the easy stuff, and it takes more energy to get the fossil fuels that are there now than we get out of them. That's the point that we're coming to, and we've also got climate change to add to that. We've got declining water quality, biodiversity, wild fisheries, so a huge number of people are fed by wild fisheries, and they're declining. Antibiotic resistance, which I'm sure you're all aware of, many more things happening. And so this is the crucial issue for us. This is the thing that I listened to the budget or bits of it yesterday, and I just want to slam my head into the desk because they have no idea of the real issues. You know, the things that I'm talking about today, they never mention. It's not terrorism. Terrorism's the last thing we should be worried about. There's much more important things, and the Kardashians as well. Here's some of the really scary things that are happening. So by 2050, if we keep doing what we're doing in our oceans, we won't have any fish left in them. So that food supply is gone. Freshwater biodiversity declining hugely. So a lot of people dependent on freshwater fisheries as well. Tropical forests, fertilizer consumption, all of these things that I'll outline coming up. But it's the foundations of how we grow our food. We are undermining the water that we need to grow the food. We're polluting and we're overtaking from many of the aquifers in the world. We're taking it out faster than it's being replaced. New Zealand's just a classic case study for how to mismanage the environment and reduce our opportunities to change that in the future, and I'll give some more details of that. But just think about the growing population and the amount of land available to feed those people. And the whole, I started on nitrogen, looking at it because nitrogen is the big impact in our rivers, and a lot of my work was showing this. But when I looked at where do we get our nitrogen from, it turns out that a third of what the nitrogen we use in New Zealand comes from the Maui gas fields and 2/3 from the Middle East. So it's artificially created nitrogen. We make it from fossil fuels. So the food that we're eating today, a big proportion of it, and most of the dairy that's produced in this country is eating the past. It's fossil milk that we're making. So if you look at that reddish dotted line there, that shows you how many people we would feed on this planet if it wasn't just for synthetic nitrogen. So that line there, about 3.5 billion, about half of what we have now could be fed if we didn't add fossil nitrogen. So this process that we discovered in early last century to be able to take fossil fuels and then use the energy to extract the nitrogen from the atmosphere and then use it for fertilizer that causes all of these problems, has driven this thing that we call has been called the green revolution. But it's really just a fossil fuel revolution. So we also have the issue of, you know, somewhere around 1/6 or 1/7 of the people on the world suffering from inadequate diet, so basically starving, and another couple of billion that are suffering from obesity, and that move towards the highly processed foods and all the problems, the health problems that come with that. Back to this EROI again, this energy return on energy invested. Around 70 is what it was around the middle of last century. So for every unit of energy, for every 70 units of energy we spent 1 unit. Globally, it's down to about 15 now. So every 15 units of energy costs us a unit. If it gets below about 14, our economies start to crash. A lot of work that Charlie Hall's done and others in the States. If you think about the things at the top, arts and education and medicine, are the things that you have to have some discretionary income in society to be able to afford those things. And they're the first things that disappear, because in the economic system, so much of the energy in the system has to go back to getting the fossil fuels. So we got some big issues coming with that. And the trouble is that our food system has become so dependent on energy. At the same time as we're running out of it, we're becoming more and more dependent on it. So depending on what you're eating, somewhere between 10 if it's plant-based food and 33 if it's animal-based food, units of fossil energy required to get 1 unit of energy out of that to us. I mean, we have that basic energy requirement just to keep ourselves alive and ticking over. We're spending somewhere between 10 and 33 fossil fuel units to get every 1 unit to keep us alive. And obviously that's completely unsustainable. Once we started eating oil, that's when we enabled this massive population increase that we have now. And if you wanted the reality of it, then the estimates are around, without the fossil fuel subsidy, about 200 million humans could be supported by this planet. So we're about 98% or something overshot, and that's completely fossil fuel driven. So to give you an idea of graphically just how much humans dominate this planet, I just want to, I've got this little graphic coming up, but I want to ask you the question to think about it first. If we took humans and all of the animals we eat and the pets that we have, our domestic animals, so we take humans and our animals and put them in one side of the scale, and we have wild animals. This is talking about mammals on the planet, and talk about the weight of them. What do you think the balance would be? You know, do you think it'll be about 60% humans and their animals and 40% wild animals? Any guesses? It's 98% us and the things we eat, and 2% of the biomass on the planet is wild animals. Think about it. That's how much we dominate this planet. And it's not hard to imagine why we have a biodiversity crisis like at no other time on the history of this planet, when that kind of imbalance of one species over all of the rest, you know, there's just nothing left for the wild animals. Our farming systems are leaky, really, really leaky, the way we do farming now. So we talk about nitrogen again. Of that, remember, it's all coming from fossils, or the stuff that I'm talking about here. Of the nitrogen that's applied to the land, about 17% of it makes it into the food, which means that 83% of it is lost. And that's the problem. For every 100 kilograms of fertilizer, only about a kilogram ends up as nitrous oxide in the atmosphere. And nitrous oxide is a greenhouse gas 300 times more potent than carbon. So carbon dioxide. So that's, you know, and that one is argued maybe up to 3, depending on who you talk to, because it's very hard to measure. We can see that in the atmosphere. We've gone from 270 parts per billion of nitrogen in the atmosphere up to 320 now, because we've just completely altered the nitrogen cycle. And what happens with all that excess nitrogen is we get this, what we see in our rivers with this, the green algae that you can see here, but also in our oceans. We've got, the count is about 400 dead zones in oceans where there's just so much nutrient and mostly nitrogen that goes out there that drives algal growth, that causes the oxygen to be taken out of the water and kills everything in there. If you want to see in New Zealand, the hot spots are the red areas there. They are the areas where the nitrogen levels in the river have exceeded the ability of the waterway to be able to handle that. So this is the ANZAC is Australian and New Zealand, the Australasian guidelines, and that's the trigger for where the nitrogen level gets to the point where the ecosystem can't handle it anymore. 44% of our lakes have reached that area, and if you want to see what's causing it, I think most of us in this room will know that Southland, Canterbury, Hawke's Bay, Taranaki, Manawatu and Waikato. These are the dairy farming areas of New Zealand. That's where our issues are. And that little graph on the right there is just the last about 400 or 500 sites from around New Zealand that we collated the data for. What it's showing is how many sites exceed that. The black line is the pasture sites, so they're the ones in pasture catchments. So about 40% and going up to 67% and rising exceed that limit. And I just put in the native sites down the bottom there just to show you they wriggle around a bit, but mostly less than 5% of those sites exceed it. And that's the one, they've got some development going on them. So this is where the issue comes from in New Zealand. But if we look at the money side of the thing, that's the interesting part of it. So if you think about, okay, so we're putting all this fossil nitrogen onto the land, it must be really good. We must be getting something out of it. Well, they're spending, this is the some European Union work where they get a benefit of somewhere between 20 and 80 billion euros when you add in the long-term gains. But the cost to society of that is somewhere between 70 and 320 billion dollars a year. And it's very similar here. One sector makes some money out of it. The rest of society is left with the costs for that. The costs to clean up nitrate in fresh water in New Zealand, somewhere between 2.4 billion and 24 billion dollars is the cost to clean that up. That's some papers that I've done on it, and that's basing it on what we're spending at the moment to clean up or to stop nitrogen getting into our lakes. So one of the classic examples is Lake Rotorua, where we are current, and Lake Taupo was the same. We taxpayers have paid many millions of dollars to stop farmers from farming. So in Lake Rotorua at present, it's been worked out that 100 tonnes less nitrogen has to go into Lake Rotorua to stop it from becoming more polluted. We've got $40 million worth of taxpayers funding to stop that from happening. So what they're doing is paying the farmers to stop farming. They've had one or two sign up already. The farmer's getting paid, depending on the size of the farm, somewhere around $6 million each to stop farming. So we're paying $400 a kilogram to polluters to stop them polluting. I have problems with that, but I also like the fact that we're stopping it rather than trying to clean it up afterwards. To give you an idea of the difference between the two, it would cost to not put a ton of nitrogen on a farm in the Rotorua catchment, cost the farmer at the top milk price around $6,000 loss of profit to not put that ton on. To get that ton of nitrogen out of the lake, the only way is to use floating wetlands, and that costs a minimum of $240,000 to get it out. So $6,000 not to do it, $240,000 to try and clean it up. And you know, if you thought about getting 100 tons out of the Lake Rotorua by using floating wetlands, you know, so rather than upsetting the farmers, do it the other way around, you wouldn't have any lake left. You'd have to cover the whole lake in floating wetlands to be able to pull that much out. So it's just nuts. So we've got one lot of taxpayers' money going in to pay farmers in certain catchments not to farm. 400 million plus some more in the budget from asset sales going to subsidise irrigation, which will mean more intensification. So a clever farmer could get paid out from one, then go and get subsidised into another one, and then get paid out for that one at some later point. Because why is it that Lake Rotorua and Lake Taupo is so important that we'll pay farmers not to farm there when we allow and actually support them farming in other parts of the country to do the same amount of damage? Just to show you that it's not just me saying this. This is some work from Scion, our forestry CRI. They were looking at 2,600 roughly hectares in the Central Plateau. They did this big study. They looked at things like employment and greenhouse gas emissions and pollution. And the two columns there are just looking at dairy and forestry, and the bottom line there is the externalities. And it's not 31 million versus 18 million. It's 31 million plus for forestry, and it's negative $18 million for dairy. So when you put the costs, and this is Scion, not me, when you put the costs on dairy, 2,600 hectares in the Central Plateau costs us $18 million a year, and forestry would make us $31 million. And certainly forestry is not a great example, because we could do much better things than we do with forestry rather than shipping unprocessed logs overseas. But that was at $7 a kilogram for carbon. It's now at $17. So the difference between those two would be huge. So what we're doing is just plain stupid. And I'll give you more examples of why it's stupid from a health point of view as well. But anyway, Now to climate change. This is obviously a huge part of this issue. If we want to have a 50% chance of keeping global warming less than 2%, and 2%, is probably going to kill a lot of people and be really tough. But even if we accept that 2% is a reasonable target, then the whole world has a budget of 260 billion tonnes of carbon dioxide left to emit. At the rate we're doing it at the moment, about 25 years. But if we share that out evenly, that budget, that allowance over all people, then looking at New Zealand's population, then we've got 150 million tonnes that we as a country can emit. So if we work that out, we've got 11, we're emitting currently net 11 million tonnes a year. So 14 years we have to get to zero carbon. So it's not way off in the distance like these politicians imply. We have to do something really, really quickly. So how are we going? That little graph on the right shows our agricultural greenhouse gas emissions over the last 4 years. Actually, the numbers have just come out for today and for this year, and it's plateaued a little bit. That was just because we had a drought and we had agricultural emissions flatten. So we're not winning there at all. So let's think about what we could do as individuals, and because this is, I'm forced to look for a way that there's a solution. And so if we look at where the problem is, we hear so often that it's all about transport and doing stuff about how we live in our houses and how we move around and all that kind of thing. And for some reason, the agricultural emissions are very rarely talked about. So around 15% of all anthropogenic greenhouse gas emissions come from livestock. 37% of that is methane. 65% of all nitrous oxide emissions come from animals. And within livestock, half of the emissions are methane and about a quarter of nitrous oxide and carbon dioxide under that. About 41% from beef and 20% from milk and dairy. But ruminants are the really big part of all of those animals that are involved in there. So 3.6 billion domestic ruminants on the planet, about 80% of all of the total livestock-related greenhouse gas emissions come from those ruminants. So that's where the issues are and the things that we need to change. So just to think about how we could make a difference, the biggest difference we can make is what we eat. And you guys all know all about the health benefits of changing what we eat, but I'm just looking at here greenhouse gas emissions we've got per gram of protein in the bottom, then per serving, and then per kilocalorie up the top. And you can see clearly the ruminants are the worst, then poultry and pork. So the monogastrics are still quite high there. Really interesting numbers around there. The fish side of things, people often think that fish doesn't have problems, but it does. Really big issues there. Then we've got eggs and dairy and butter, and then all the fruits and sugars and things there, maize and wheat. The highest out of all of those other things, the non-animal ones, is rice, but still way less than the animal stuff. Apart from greenhouse gas emissions, okay, so when we just look at livestock, more than half of the sedimentation of waterways throughout the world is caused through livestock. 37% of pesticide use is related to livestock. 50% of total antibiotic use on the planet is livestock. So obviously, those issues that we're talking about with human health, there's a big part of the problem there. 64% of ammonia, 33% of total nitrogen and phosphorus leaking to waterways comes from livestock agriculture. When we look at the numbers have been done, I don't know if anyone's done this in New Zealand. I was using some information from the European Union and from the States. And these are some estimates there. About $1.5 trillion could be saved by reducing meat, greenhouse gas emissions, and because they're healthier diets as well. And that the changes that would happen there, huge economic impacts from that as well. Eutrophication, which is the pollution that I already talked about there, but red meat is clearly the highest there. So just to give you an idea of the nitrogen load there, so 1 kilogram of red meat would generate 150 grams of nitrogen equivalent emissions, which are those 300 times greater than carbon. And compare that with 1 kilogram of cereal, would end up with 2.6 grams of nitrogen. So big differences in how much nitrogen is lost to the environment as well. And when it comes to water use, 8 times more water per kilogram for a meat diet than vegetarian, and that eutrophication. There's just some graphs here showing some big kind of global studies, and you can see there's big error bars there, but clearly red meat is right out there in front, sort of followed by dairy, chicken, eggs, and fish. And you've got those different parts to it, transporting, processing, all that kind of thing as well. When you look at land areas, a similar sort of story. Animals are really inefficient at doing that job. And there's certain parts of the world where you have to have animals. It's just not possible for a whole bunch of reasons to grow food directly for humans. But they're a small area. Animals can do that job. But in other places, this is from the States, looking at basically the base on the meat diet at this end of the graph, going right across to vegetarian at the other end, and looking at that, the cultivated cropland, perennial cropland and grazing land, and how much less land you need to feed a person as you change diet. So a whole bunch of reasons for changing diets. Energy is a big part of it. Now, this is a study that I was really interested in because I'm starting to do some work around modeling energy and how much energy we use. Obviously, with it declining, with fossil fuel energy, we have to think about how we can do it differently. If you look at that first graph there, that shows the proportion per capita of renewable energy that is on the planet, because I think people imagine that there's a lot more renewable energy used now, but per capita it's been reducing. That's 1950, 1975 and 1995. It's going down because there's more people. We used to, most of the renewable energy that's used is actually burning firewood to keep us warm. Globally, that is the biggest. We think about solar panels and all those kind of things, and hydro, but they're actually reducing as a proportion of the energy we use in our lives. The next one is the environmental loading ratio, which is obviously going up, and this is based on energy as well. The energy is the next graph, which is how much energy is embedded in the things that we use, and the global sustainability ratio index at the end there. The sustainability obviously is going down. There's so many ways you can measure this, but the story's the same across all these things. The trap is this agricultural treadmill. New Zealand is on the treadmill, where just look at dairy as a really good example, where we're driven by producing commodities for this international market. The pressure to keep prices down, there's the winner of the race to keep prices down for milk powder is the country that has the weakest environmental laws, the weakest labour laws, and the most fossil fuel input, because that's the cheap energy that goes into the system. You can get rid of that. So we've got, I don't know exact figures, but at the last official figures were about 70% of the dairy farm workers in the South Island were Filipinos. So we've got labour law impacts happening there. I think when we compare us with the rest of the world on our environmental regulation, we're way weaker than the others. So if we win this game, it's a race to the bottom. This is a game we do not want, a competition we do not want to win, this race to the bottom. So it just means that trying to keep prices down means more fossil fuels, means farmers working hard, the land working harder, the cows working harder, everything working harder just to stay in the same place on this treadmill, because we can't win that game, and that's definitely where we're going. Just to look at a local example, because I've been doing some work with Landcorp on an environmental reference group there, and we looked at Southland's got some big problems with dairy recently moving there, but it gets really, really wet in the wintertime, and you have these incredible situations, and I've seen it with cows up to their bellies in mud, just in big paddocks full of mud in the wintertime. There's nowhere feeding them crops, and they're just almost under. And so we looked at, well, let's just make the milk directly from the plant material, and leave the cow out and see how that works out. So we just got the comparison there between what was a great wheat growing area before dairy took over down there, wheat and oats. So we had the wheat numbers, so we calculated them out there. And so roughly 4 times as much energy per hectare leaving the cows out, twice as much protein per hectare, 14 times less greenhouse gases per tonne of product, and 40 times less if you're comparing it with irrigation. So, you know, it's hugely more efficient to actually not have the cows in it. And the biggest growth in world markets is for non-dairy dairy. So plant-based dairy products are really, really big growth model, growth for selling our products overseas. So, but one of the lessons that came out of this was, one of the things that was really important for making dairy products or milk from plant material is you have to have good clean water to do it. And so when we looked at some of the shallow bores down there in the vicinity of where a factory could go to produce this stuff, and already it's 6 times the World Health Organization limit for nitrogen in the water, for nitrate in the water. So it's about 60 milligrams per litre in the shallow bores in the vicinity here. And that's gone up from 10, which was, you know, just under the World Health Organization limit about 10 years ago. That's how fast it's going up down there. So what we're doing is we're shutting the door on future. What we're doing now is cutting down our options for the future. I don't have a lot of time to be able to talk to you, but you need to be aware we have this huge issue in this country also of cadmium contamination of our soils, because all the superphosphate that we bought in here, or the bulk of it right up until recently, came from Nauru. We stripped Nauru and brought it over here. That's why they have prisoners or whatever, refugees, you know, it's being used in that disgusting way now, because everything was stripped off that place and brought over here and put on the land. And unfortunately, it was very high in cadmium, marine-derived cadmium. It's basically bird shit. So the birds concentrated the cadmium from the ocean into there. We spread it on the land. Cadmium is I'm sure I don't have to tell you, but it's a carcinogen. We found it to be a neurotoxin with fish at very low levels with the native fish that I've been working on. But that's an option for the future, because what happens is plants take up cadmium. The cows don't pass it on to the milk. That's why we would have been banned from our markets years ago. But the cows just sequester it in their livers and kidneys, and we knock them on the head long before they get cancer. So what we're doing, and we've known about this for a while, Ministry of Health, Ministry of Primary Industries has banned those organs of animals older than 2 years from being used for human consumption. So in the last total weekly intake study, and I hope that I can find some people here that have been looking at the most recent one, but the last one that I had the results for in 2009, all of our children up to the age of 17 exceeded the European Union standard for cadmium intake. So we know it's a big issue. The other bit of it that you can ask me about if you're interested, but that because it can't be used for human use, where's it going? I posed this question a few years ago at a Massey seminar, and one of the vets there, Nick Cave, not the singer, but one of our vet researchers, he looked at it and found really high levels in our pet foods. So it is being used in our pet food. The big pet food companies stopped using it, but you didn't hear about it because they're not going to tell you that they've got rid of something that they didn't tell you that they had in the first place, and they've kept it quiet, and they've funded a study on it, but it's really inadequate kind of stuff. So it's something that it's a classic example of shutting the door on our future options. So if we want to change to a plant-based diet, then we've got this problem of cadmium that we have to deal with somehow. So the threats to just to sum up, we've got the nitrogen bomb, which is not a bomb that blows up, but the fact that we've altered the nitrogen cycle so hugely. Greenhouse gas emissions from agriculture, especially animals. Peak phosphorus is happening. I'm sure that some of you would have heard of the ship that's being held up at the moment in South Africa, because all of our phosphate has been coming for a while now from the West, from Sahara. Well, actually, we buy it off the Moroccan royal family, who steal it off the West Saharans. So a whole lot of human social issues there as well. But 8 shiploads at least come to New Zealand. So this is our food system, reliant not on just on fossil fuels, but on fossil phosphate as well, that comes from the other side of the world. Antibiotic resistance, animal health and welfare issues that are becoming much more topical now. Human health pathogens, disease, I've got a list of them coming up. The availability of fresh water, the quality of fresh water, the pollution of it, our lakes and groundwaters. We've got the Havelock disaster. We've got heaps of disasters happening in the South Island with shallow bores and drinking water. Pollution of our estuaries and oceans that are happening. and just that dominance of the human animal food system. I got a colleague of mine, Alison Jews, who works in this area a lot. I grabbed a list off her of the waterborne and aerosol aerosol from irrigation related issues that she's doing some work with. I know some people from here are as well, but there's the list of things related to animal agriculture in this country. And if that map looks a lot like the other one, this one is the pathogens. This is the E. coli map for New Zealand. So everywhere that's dark orange or red exceeds that Ministry of Health guideline of 260 coliform units per litre, or E. coli per litre. And you can see it's those same places. It's the dairy intensive farming areas of New Zealand that exceed that limit. That's just the E. coli, the indicator. All those other issues will be bad in those areas. And especially in Canterbury with the shallow aquifers and a lot of people drinking from those shallow bores in Canterbury. Okay, so just to wrap up, this isn't new. Civilizations look back. We've done this over and over again, this thing where we over-intensify and then we have an environmental crash. This time, the big difference is we don't have somewhere else to go. We've got the whole planet involved now. We have to face up to this reality. We don't see any leadership. There's no leadership in the agriculture industry whatsoever, because most of them are in the trough making money out of the thing, so they're not talking about it. A lot, we've got these issues, and I'm sure it's the same with health, where you've got the sugar industries and the alcohol industry controlling the research, controlling the funding to some extent, and the powerful lobbying that they have with government. That means that we don't see even admitting the problem, let alone do anything about it. And I'm wondering, I know the power of these lobbyists because I've been attacked by one of them before. And the huge amount of money that gets spent on lobbying in Parliament. I wonder if we need environmental and health lobbyists to try and counteract some of that stuff and get some truth into it. So what we've got to do, and we have to do it really, really quickly, is to break this nitrogen fossil fuel addiction, which has driven this increase in food, because no matter how I look at it, it's them or us when it comes to animals. We can't have both. You saw that graphic of just how much we're taking over the planet, and when it comes to animals and agriculture, we could reduce that balance hugely by getting animals out of our diets. We have to start true cost accounting, because I'm sure it's the same in the health system. If you put the true cost of what it was going to cost to clean up after somebody's made some money selling something to somebody, then they wouldn't be able to do it in the first place. We've got to change our diets. I keep banging on about that. We have to face the fact that if you look over the time that humans have been around, and you look at the last couple of 100 years, where we've had this massive fossil fuel driven increase and change in everything we do. If you convert that to a human lifetime, it's like a crazy party that we've had for a weekend, and we've trashed the place. It's Monday morning. We've got to go to work. The house is wrecked. This is what we have to face up to. The game's over. We can't keep living like we have been. And we have to watch out for the weapons of mass distraction. The terrorism, the rubbish that gets talked about, that I heard our ministers talking about in relation to this budget, the things that they're covering up and not facing the true issues that face humans. And I know that I cop a lot of flack for being an activist, but I'm sorry, but that's our rent for living on the planet now. And if every one of us doesn't start doing something and speaking up, if we all think that we can sit back and leave someone else to do it, then we're in big trouble. We have to start doing something about it. Okay, so I've had my rant, and I'm really happy to answer any questions now. Thanks.
Thanks, Mike. We've got about 4 now questions, and if you just put your hand up and please introduce yourself. And we're using a roving mic so that remote people can hear what you're saying. Tony.
I'll speak up. Nice talking. Not very nice compliment. So what would one small country down the bottom of the South Pacific do to achieve change if the Western world isn't going to change the rules to still be economically viable?
Well, I guess like all of us can say that we're too small, and I think that's the trouble, that we all think that our little bit isn't going to make a difference, so you can extend that. I have the same problem with your average farmer can't see how just his farm makes a difference, but it's the cumulative effect of it. And so we're part of this global system, so we can lead the way with change. So I mean, economically, I don't think there's an issue in that we can change what we're doing and still make the money. We've shown that really, really easily. The reality is you can do that. What gets sold to us is that we can't do that. So I think there's two things. We have a responsibility to change the way we live, even if it means a drop in our living standards, because we won't have living standards if we don't make that change. So the leadership and the reality that it's often not as bad as it's portrayed by the industries that are making money out of the current model.
So can I just follow up, please? So you said we've shown that you can change the way you produce food and it's still economically viable. Can you please expand?
Oh, sure. Okay.
In the world context, where you're always going to have China doing what you would have China at the moment, moving into dairy if we exited it, how can we do it in a way that we maintain our economic standard of living?
Okay, well, I don't think that we can maintain our economic standard of living. I think we have to face that reality that we, like I said, we either drop a bit now and be sensible, or we lose everything. The other part of it is that we've shown, we meaning a bunch of people that I work with, that most farms, if not all farms, dairy farms could substantially reduce the number of cows that they have and still actually make more money. So there's a graph that I use of a local farm, but there's many like this, where what's happened is that we've increased how much fossil fuel energy we put into a farm, but if we were making I don't know, clothes pegs or something like that, widgets, and as long as you've got a market for it, you add more raw materials, you make more of them, there's this linear increase. What happens in biological systems is that you max out and you start to flatten. And what's happened in dairy and actually across all agriculture is we've had a reduction in productivity over the last 10 years because we keep adding more stuff, but we've plateaued on production. So actually productivity has gone into decline. So what happens then is that you can cut back on intensity quite a lot and make more money. The farmer will make more money. The dairy company, I'm not sure, and certainly the suppliers will make less money. So that's the reality, and that's what I mean by we can show. And then when you look at the growth in the markets for the non-dairy products, the non-animal-based dairy products, then people are paying a premium for that. And if we can just get out of this mindset and get into that market, there is really good money to be made, but it means changing significantly what we do. But I know we've got huge amounts of investment in dairy infrastructure, so we won't be able to suddenly get out of it. We have to reduce in around those dairy platforms and diversify on the outside. And part of that diversification, part of this model, less animals get into all kinds of other things, including tourism. So the idea of a modern dairy farm in New Zealand it'll have trees and bees and vegetables and all kinds of things grown on that land. Plus, so the upside of that is they become much more pleasant places to be as well, rather than a monoculture where you've knocked everything down for a pivot irrigator. And then you can pick up on this tourism market that we have at the moment, and there'll be really popular places to visit and have houses on and that kind of thing. So there is a vision for a better one.
Thank you.
Oh, there's.
Yeah, I'm quite convinced that the plant-based diet is good, but if you go to a typical restaurant, you'll probably mostly get soy products in your food.
Yeah.
And there seem to be quite a lot of questions about large-scale soy production. Could you?
It's a really important point that that just taking out of the cows or animals out of the picture doesn't solve the problem if you end up going back into the same intensification trap that you were in before. You can get on that treadmill without the cows, without the animals. So yes, we have to be much more aware of how we use the land. So agroecology, sort of biodynamic system. No, I don't want to use that word. Biological farming is definitely a much improved. We can't just go from, one crazy over-intensified system to another with plants. So we have to be very careful with that as well. It's a really good point.
Thanks, Mike. We were introducing ourselves, were we?
Yes.
Yeah, Jeff Simmons from the Opportunities Party currently. Mike, you mentioned that there's a bit of land that isn't useful for much else apart from animal agriculture. And of course, our industry argues that New Zealand has a lot of that land. Just wondered if you had a response to that.
Yeah, I mean, we do have a lot of that land. A lot of that land could be used for forestry as well and for carbon sequestration. It doesn't have to be animals. I think that the carbon market is probably better than what the milk market might be in the future. So I think, there are undoubtedly parts of the landscape that have to be like that, I think, globally, but not necessarily in New Zealand, and that we have to think about all kinds of uses, but trees would be a big part of that, and not just pine trees either, but getting into other things. Yeah.
Hello, Maya Hamasal. I'm a writer and environmentalist. I just wanted to pick up on the point you made about soy, and I totally get that. And when you say about going to a restaurant and it's all soy-based products, I think that's around because at this moment we live in a society that's very prejudiced, shall we say, towards meat eating. So when you think of alternate diets, you think, oh, well, soy or tofu. If you're vegetarian or vegan, that's what you eat. And it's around the fact that people at the moment are not educated as to what a plant-based diet actually is. And people look at kind of, tomato on pasta and think, oh God, I wouldn't want to eat that. Or tofu that's really kind of, floating in a bit of soy sauce, and you think, what, is that the alternative? Move into a system where there's more plant-based foods, people will start to understand what it is, and you'll see that there's a whole range of plants out there that can be eaten, much more exciting food to be had, and hopefully, sort of restaurants and chefs and what have you will be sort of picking up on that, and we won't just have soya. That's my vision. That's a really good point. Yeah, I think that change is happening, and it's not the dread that everybody seems to make out it is. It's just a lack of imagination mostly that is the problem. Yeah.
Time for one or two more quick questions. Just introduce yourself.
Hi, my name's Jane. I'm a PhD student. I'm just wondering what you think of laboratory grown meat, whether that could be a good way forward.
Yeah, I think that, well, certainly I don't know enough about the laboratory grown stuff, but there's certainly the meat alternatives, that are made from plant, based protein. I see them as a bit like vaping for smokers. It's a way out of the addiction, and so they can have something that looks like meat and they can pretend it's meat, and for most people they can't tell it's not meat. The thing that I'm a bit worried about is that, again, that trap that we talked about before is because we have that Sun-Fed Foods in New Zealand that's selling, meat imitation, and they're actually buying the plant protein from overseas, and it's probably soy protein, and it's probably not, well, the system that it comes from could be just as dodgy. So, I mean, it's a trap. So, but I like the idea of if people have to have meat, that growing it in a cell, rather than big animals using up all of that energy and doing all the destruction they do. If you could cut out that whole process, then I think, it could be a good thing. Yeah.
Actually, I just have one question, and that was really about where is the academic and research leadership in this area, apart from people like yourself? Because I think New Zealand's prided itself on having a large agriculture research base and some world-class scientists. Why is there not a concerted strategic move towards identifying and responding to this really appalling litany of problems that are not distant problems, they're problems now? Can you just comment on where you see the leadership coming in the future?
I think that I'm probably a good example of Speaking out like I do about agriculture within an agricultural university makes me not the most popular person in the place, and a lot of the funding comes from you know, from the agriculture industry into our university. I imagine that you could probably say the same thing about some of the health issues when it comes to alcohol and sugar. Where are the academics and the leaders? We know there's a few of them, but I don't know that they get a huge amount of support. So we all need to step up to the influence of big business, and you know, our role as critic and conscience, we have to be more vocal, I think, because we're the only ones that are in the independent position to be able to do that. So, yeah.
Great. Well, at that point, I really want to thank Mike very much for coming along. I've very rarely heard a talk where I've seen exposed to so many, I'd say, shocking new bits of information that I wasn't aware of before. I wasn't aware of the cadmium example in particular. And I just think it shows the importance. I mean, we are many of us are in the public health field, of the need to work with people like you who have expertise, and the fact that these are all an interrelated set of critical issues. So I really congratulate you on standing up, being a prominent advocate, science-based advocate for these critical issues. And, you know, I hope we hear more from you in the future. So thank you very much.
Thank you.